Hey guys, welcome to another video. In this video, we are going to solve this question. It says that show that this determinant is equal to these factors, okay, using the properties of the determinant. So our main goal is to use the properties of determinant to take out some scalars and prove that this determinant is indeed equal to this, okay? So we have that this one is C1, C2 and C3, and we have R1, R2 and R3. So while performing the operations, we have to make sure that we get some of these factors, okay, in the columns or rows, okay. If I perform this operation to row 1, which is that I want to subtract row 1 by row 2, which is same as I am adding negative of row 2 to row 1, right? So by doing this, I'm saying that in this column 2, my factors will be x plus y minus of z, right? So my y will get cancelled. So I will be left with x minus of z. And here I have z minus of x. So how can I change this to z minus of x? I can take negative of z minus of x to match these factors, okay? And if I perform row 2 by subtracting the row 2 by row 3, which is same as that I'm operating minus of row 3 and adding to row 2, then what I will get is that for this factor I will get y plus z minus of x. So z will get cancelled, so I will get y minus of x, right? So here I have x minus of y. So how can I change this? As same as before, minus of x minus of y, such that when I multiply, this negative will turn to positive and we will get the factors, okay? So by doing this, we will get now 1 minus 1 is 0, and here I got x minus z, and here x squared minus z squared, and here also row 2 minus row 3, so 1 minus 1 is 0, and here I will get y minus of x, and here y squared minus x squared, and we didn't perform any operation to row 3, so it will remain as it is. It will be 1 z plus x and z squared plus x squared, okay, like this. So this is the result after the first set of operations. Now if you observe very carefully, we can write these and these as the factors because they are the differences of the squares. So we can express this x squared minus z squared as x plus z times x minus z, same to y squared minus x squared. By doing this, we will get 0, 0, 1, x minus z, okay, y minus x and z plus x. Here I will modify these to factors. They are x minus z, x plus z, right? And here y minus x, y plus x, and here z squared plus x squared, okay? Now this is where we have to use the properties of the determinant. If you observe very carefully in this row 1 and row 2, you can see that they have this common x minus z and x minus z, okay? Here y minus x and y minus x. So we can treat these as a scalar, okay? So that we can take out the scalar to evaluate our new determinant. So we have the properties of determinant that if any entire rows or columns are multiplied by the scalar k, which can be complex or real number, then our new determinant will be that factor times old determinant, right? So our new determinant will be x minus z, okay, from the row 1 and y minus x from the row 2 and our new determinant. This are our new determinant, and this is our old determinant, which is 0 1 x plus z, 0 1 y plus x, and 1 z plus x, z squared plus x squared. Okay, so this is our new determinant. So we are using the properties of the determinant to evaluate this determinant. Okay, now if you observe very carefully, in this column 1, these two entries are 0, but only we have one entry that is non-zero, right? So if we expand to calculate the determinant through this column 1, then we need to only account for the minors of this number, right? So it will be very easy if we expand through the column 1, right? So here this one is that by taking x minus z from row 1 and y minus x from row 2 as scalars. Okay, we got this. Now by expanding through the column 1, which is expanding through C1 column 1, we get now that our determinant will be x minus z y minus of x times. To get that, we have to delete this row and delete this column, right, to account for the minor. Okay, so we'll get 1 times this factor minus this factor, right? So we'll get y plus x minus x plus z. Okay, so this is our determinant. Now our determinant got simplified to this one, and now our final determinant will be just x minus z times y minus x times, here if you observe carefully, we have this x and negative x, so it will get cancelled, so we'll get y minus of z. Okay, so these are our factors and they are our value of the determinant. Okay, so if you observe very carefully, in the original factors we have x minus y, y minus z, and z minus x, which is x minus y, y minus z, and z minus x, z minus x. So here we got y minus z as same here, this factor, but we didn't get x minus y, we got opposite of this, and this z minus x, x minus z. So how can we make these and these to z minus x? As it is simple, that I've told in earlier time, that is by taking the negative of it. Okay, so I will get now our final value of determinant is determinant equals to, here I can take negative of z minus x times, okay, here I can take negative of x minus y times this y minus z, so that this negative and this negative will get positive, right? So our final determinant is x minus y, y minus z, and z minus of x. With this, we have successfully shown that the whole determinant is same as this factor by following the properties of the determinant and by performing the elementary column and row operations. I hope you all would have enjoyed this video, and I will see you in next video when I upload more questions. Bye bye.